We are going through exercise 17D, and in this video we'll be answering question 5, which says which of the graphs labeled A to F correspond to each of the graphs labeled A to F. So what it's asking us to do here is to match up a graph to its derivative graph. Now you might be thinking to yourself, do we need to do some sort of fancy maths in order to do this? And in fact, because we're just doing a general sketch, we're not finding intercepts or anything like that, it's really not that hard at all. So what I'm going to do is just go through these first 3 examples first. So let's come down here and see if we can graph the derivative of it. So let's come down here and let's graph these derivatives. The first thing that we need to realize is that if I were to draw the derivative of this graph, well, this y-axis or the vertical axis is now going to be my derivative. It's going to be dy dx. So let me come and get my pen and say this is going to be dy dx. So that's going to be my vertical axis. My x-axis is still my x-axis. Okay, let's now look at this and see what we can decipher. The first thing we have to realize is that from this point to this point, as you can see, I'm going down. So it's going to be negative, 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 negative. But then I get to this point right here. And this point right here, the derivative is going to be 0. And we can think of this in terms of if I were to draw a tangent at this point, that's a horrible tangent. If I was to draw a tangent at this point, the gradient of that tangent is going to be 0 because the gradient of a horizontal line is just 0. So that means if I was to represent that right here, I need to represent that my derivative is going to be 0. Well, it's just going to be right here. I've literally found that. I can line it up and I can just plop it down here. Perfect. Let's now continue. Let me get into the color. From here to here, so this is clearly going to have a positive derivative because it's going up. My gradient is going to go up, up, up. Perfect. So let's see if we can graph this now. First thing that we have to realize is that because I have a negative derivative here because it's going down, that means for my graph down here, it's going to be below the x-axis. That makes sense because below the x-axis is where I have my negative numbers. So if I have a negative derivative, as I do here, because it's going down, it's going to have to exist down here. Then it's going to have 0, so it's going to intersect at this point. And then, as you can see here, I have a positive derivative. So that means I'm going to highlight everywhere above the x-axis. Perfect. Now, I just need to draw a graph representing these truths. So I'm going to grab a line and I'm going to draw it up like this. And just like that, we are done. That is what our graph is going to look like. So as you can see, I have a negative derivative, as I do here. Then I have my 0 derivative, as I do here. And then it goes up. So I have my positive. Okay, let's now continue here doing the same thing. So here, what do I have? Well, it's going to be positive, 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 positive derivative because it's going up. I then have a stationary point. Stationary point, it is what it means, you know. The derivative is 0 at that point. It's stationary because if I was to draw a tangent there, it's just going to be a straight line. So let me now plop that down. So I'm literally just drawing a straight line. My derivative is going to be 0. So when x is whatever this is, my derivative will be 0. So remember, this is dy dx. It is my derivative. This is my x. Then let's continue. Then I'm going to have negative, 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 negative derivative because it's going down. And then I'm going to have another stationary point. So let me plop that down. Perfect. And then I'm going to be positive again because it's going up. Positive, positive, positive. Okay. Now let's come and do some highlighting. So because I have a positive derivative here, because it's going up, it's going to exist above my x-axis. How easy is that? Then I have my stationary point, so it's going to intersect the x-axis. Then it's going to be negative. So that means between these points, it's going to be negative. And then to the right of this, it's going to be positive because it's going up. So I'm just highlighting the regions where I'm going to draw. Now I'm going to draw. I'm going to grab this. Come on. There we go. There we go. It's going to look something like this. So it's a quadratic. So hopefully you can see here, I had a cubic here, which turned into a quadratic. I had a quadratic that turned into a linear function. So it's always dropping one down in power, which we've seen before. So as you can see, I'm going up, up, up. It has a positive derivative, so it's in the positive area here. Then it's 0, then it's negative, then it's positive. Okay, let's now do the next one. Hopefully you're probably getting the idea of it by now. You're probably thinking, I get it, we don't have to do another one, but let's do it anyway. So this is going to be negative, 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 and then it has a stationary point. So let me plop that down. I keep saying plop. Plot that down. You know what I mean. Then let's keep on going. This is going to be negative, negative, negative. Oh, look, there's lots of negatives here. Then stationary point. Bring that down. Now I need to draw, wait, let me continue. Then it's going to be negative, negative, negative again. Okay, so this is going to be one funky looking graph because it's going to be negative here because I have a negative derivative because this is negative. Then it's going to touch the x-axis. Then it's going to be negative again because this is negative. So it's going to be below the x-axis again. Okay, that's weird. And then it's going to touch there again, and then it's going to be negative again. So this is going to be one weird looking graph. But we persevered. So ready? It's going to be negative. Then it's going to touch. Then it's going to go down. Then it's going to go up. Then it's going to go negative again. All right, that's a horrible graph, but it represents what our derivative is going to look like. Okay, so hopefully that kind of makes it very clear as to how we think in our head of what the derivative is going to look like. Of course, if we were to figure out what these points are, there'd be a lot of maths involved there, but because we're just doing a rough sketch, we don't have to worry about that. So let's now zoom back out and answer this question. So hopefully what you can see is the real point that's really important is realizing that if you can find your stationary point here, then you can say, all right, I have a stationary point that looks like x equals 0, and look, here's that there. And you can also see it's negative, 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 as this is in the negative region, then it's positive, 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 as this is in the positive region. So that means this right here is going to be B. So to here, I'm going to have a stationary point here and a stationary point here. So a stationary point here and a stationary point here. And look, a stationary point here, stationary point here, and it's got the same thing as we were talking about before. So this is going to be C. This is our funky looking graph. This is going to be D. This one here, I have a stationary point here, which means I'm going to have, for my derivative, a stationary point there. I come and look over here. Look, there it is right there. And then you can also double check this by going, okay, it's positive, just as this is positive. And then, actually, I don't want to put positives here. I might just, it's in the positive region, right? And then this has a negative gradient, negative, 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 and this has a negative values there. So that checks out as well. So let me come here and say this is going to be A. So B, C, D, A. This right here, well, it's just a straight line. So the gradient is going to be 0. And this one here has a gradient of 0. So it's going to be F. And then this right here, sorry, this one right here, this has a continuous. It's continuously positive. It's only positive. Therefore, what that means is that my derivative would only exist above the x-axis. And that's going to be right there. So this is going to be E. And we are done. Hopefully all that made sense to you and you have a good conceptual understanding of what it means to graph the derivative.